In this example, we will take a simple transaction between two parties. In this transaction, Helen borrows $1,250 from John. Helen and John also record their transactions in their own accounting books. They decide to meet in a cafe and exchange the money. After the money was exchanged, both make a note in their accounting books. Helen agrees to repay the loan in 3 months. Their accounting book entries could be: John paid $1,250. Helen received $1,250 to be repaid in 3 months. Let us say after 3 months, John requests for return of the loan. Unfortunately, Helen has lost her account book and is not sure whether this transaction is already settled. She is also not sure about the exact amount. This results in a dispute. To resolve this dispute, both John and Helen have to go through many reconciliation and validation efforts. This results in significant usage of time and resources, as well as possible damage to their friendship. Let us take the same scenario in a different setting. John and Helen are part of a friends circle who meet regularly. They also exchange money and assets based on their needs and keep track of them. All of them keep an accounting book for the group to record any of the transactions which happen in the group. Helen borrowed the money from John, and every member of the friends circle makes an entry in their accounting books. Helen also agrees to repay the money in their meeting 3 months from that date. Let us assume that Helen lost her accounting book, but in this scenario, the transaction is recorded by all the friends in the group, so there is proof and no dispute. This is a simple example of the power of distribution and decentralization. It helps in resolving disputes in a trustless environment. The example we discussed is a financial transaction. However, it could be used for any type of actions or data which are deemed important for the group members. Distribution of ledger among multiple parties and its validation is a key feature of blockchain, which helps in conducting trustable transactions in a trustless environment. Let us now look at a consensus feature, the rules and agreements to update a decentralized ledger. This brings us to the second key feature of blockchain technology. Let us go back to our example of Helen and John to understand consensus in more simplified terms. As we have seen, once the transaction is done, everyone in the group enters the transaction in their accounting book. To make sure that everyone enters the transaction and it is free from tampering, the group follows a simple protocol. Once the transaction is completed, they approve the transaction by show of hands, similar to simple voting. If they agree to enter the transaction, they also make sure that it's written with a marker pen, which prevents it from being erased from the accounting books, and complete it before the end of their meeting. They follow this protocol to make sure that it is tamper-proof and is recorded in an orderly manner with common agreement. This is an example of consensus. We saw this in a simple group setting. However, in a widely distributed and decentralized blockchain network, different frameworks use different algorithms to make sure that the ledgers are fault-tolerant and tamper-proof. Proof of work, proof of stake, etc. are some of the examples of the algorithms used by blockchain frameworks, which are more complex than the simple protocol which we followed in the group. These algorithms are not new, but have been developed over years to provide fault tolerance for distributed systems and processes. Let us once again take the example of Helen and John to understand smart contracts in a distributed environment. We saw that everyone in the group maintains a group accounting book or accounting ledger to record the transactions, and they follow a protocol while entering the transactions. How do you ensure that everyone records the transaction in a similar way so that it could be understood many days later? To address this issue, the group decides on a certain format and validations while entering the transaction. For example, they enter the lender's name first, and as a validation, it has to be a member of the group. Next, they enter the borrower's name, who also has to be a member of the group. They will then enter the loan money, which has to be numeric with 2 decimal places. This is followed by the transaction date, which is the same day they approve the transaction. They would also enter the promised return date, as agreed by the borrower, which has to be a future date. In addition, they also collect the signatures of the borrower and the lender. This is a simple business rule they follow for any borrow money transactions. This ensures that everyone follows the same rules and validations in creating the transactions, and they have the same transaction record. In a distributed or decentralized blockchain application, these automated business rules are known as smart contracts and are used uniformly across all the participants in the system. Different frameworks provide different coding options for creating smart contracts in their network. Those options are deployed across all the participants in the network. The smart contracts are also immutable.